So today we'll learn about introductions, about all other sensors, and about Arduino, then how to code Arduino, basics of coding and all. So how many know basics of Arduino? Like anyone has seen Arduino board used? You can raise your hands. No response. No one raised your hands. Only one. At least like seen the Arduino board at least. Can raise your hands. Okay, all are new to this. Okay, 2-hand raise. Okay, fine. We'll look into the Arduino board today now. So I'll share my screen. Is my screen shared? Is it visible?
Yes, bro.
Oh, okay, fine. So first, no, we'll do in the software thing. Okay, like we'll use Arduino in Tinkercad software. In hardware and software, there is no much difference. Both are same only, but only the booting thing will differ. Like you need an external hardware cable to boot, and you should use. Oh, your internet is slow. Okay, so you need a cable and you need Arduino IDLEs to write the code and all. For now to learn, we can use software and we can learn. We have other sensors, everything in software. So we'll use software only. So first we'll look into tinkercad.com. And there I net correct time change there. You can join the class through mobile and you can work parallelly in your systems. So just type tinkercad.com and you can go to the first link. It came directly. Okay. So you can sign in. If you are new to this, then you can join and sign in with Google directly. My screen is visible, right? If any issue like my voice is not coming or screen is not visible, then just put a message in WhatsApp. Your voice is not audible. I'm audible, right?
Yes, bro.
Yeah, someone sent me that you are not. You should join with like in Zoom. You should join with audio. Then only you can hear the voice. So if you're missing that, just do it. So in this Tinkercad, it is for mechanical guys. They can present 3D things and 3D designs. Then for electronic students, we can use circuits and do all circuit stuffs. So we'll go with the circuits and create new circuit. Actually, yesterday I created the new circuit. It's empty here. So I'll just open that directly. You people can go with create new circuit and it will open a page where you can play with this. Okay. Anyone has used Tinkercad? I think many have used Tinkercad in their STEC classes. MIT app inventors, if they have taken app development, then they would have used Arduino also. Hand raise, anyone has used this Tinkercad before? Sorry guys, got disconnected. So it is recording. Okay, fine. So 10 members are there. Okay, I'll share my screen, just confirm me. I'm audible, right? You're not audible, bro. I'm audible now. Hello. Hello. One second, guys. I'll change my network. Okay, am I audible now? Hello. Wasim, hello.
Yes, bro.
Yeah, I've changed my network. So, is my screen visible now?
Yeah, it's visible, bro.
Yeah, okay. So this is Tinkercad platform. So you here first whenever you come now you keep this to all. Don't keep in basics because in all you can see everything available. In basics only basics things will be visible. You can search here whatever you want, a resistor, a LED, anything. Like many are available. Still many to be added to the software. So for basics things we can use this like available things now. So you can see first section, what is this? General section, we have resistor, capacitor, inductor, Zener diode, diodes. In input, we have switches, photodiode, sensors like ultrasonic sensor, flex sensor, IR sensors, many sensors are. You can go through this software slowly and you can check. We have output LEDs, other motors, everything. Even we have 16 cross 2 LCD display also. So anyone wants to like work with the LCD displays, you can connect those and you can practice here. In software, like if we do wrong connections also, that doesn't affect. So you play with the software first, then go with the hardware. It is better to do that. If you mess up with the hardware, then hardware will burn up. So then we have batteries, different kind of batteries, 9 volt, 1.5 volt, 3 volts, solar cell also, then breadboard, then microcontrollers. So here we have four types of microcontroller. Um, then instruments, we have CRO, we have function generator, we have power supply, multimeter. Then in ICs, we have all ICs we have studied right now. Like we have 555 timer IC, we have op-amp, then we have transistors. Also, we have this voltage controllers. I mean, this what to say, 7805 and all. Yeah, voltage regulators. So 5 volt voltage regulator. The 7805 IC. So this software gives you many ICs, many other things. So you can connect them and you can work with them. So first we'll look into this Arduino board. So we have Arduino board here. So this is the Arduino board. We have different types of Arduino board also, which we buy for 400, 500 is not the original Arduino board. Original Arduino, this is an Uno board. In Arduino also we have different types like Nano, Mega, and other things also, which differs in their size and pins, number of pins like output and digital pins and analog pins. So generally we'll use Uno board. So Here in this board, this like China made and all, you'll get for 400 to 500 rupees. The original will cost you around 1.5 to 2K, which is Italian made, I guess. That is original board. Normally we use this duplicate China made boards only, which is cheap in cost. So now, if you look into this Arduino board, this is the main microcontroller. My cursor is visible, right? Anyone can respond me.
Yes.
Yeah. So this long bar thing, this is the IC, which is microcontroller IC. We have studied 8051, right? So this is not 8051 microcontroller. This is Atmega 328P or 328, we can say. So we have different types of microcontroller also. This one is Atmega 328, 328P or 328. So this section will have in original hardware, we can see the microcontroller here. You can remove that microcontroller and you can like use it in different ways also. But this is a module, okay? For this, we have a crystal oscillator. If you take only IC, then you should integrate many other things. You should connect an crystal oscillator to run the microcontroller. So they have simplified us with this all connections. Like they have given this thing, right? This is the what to say, this is an oscillator. Then we have other power factors, like we should also look into power factors and everything. They have done the circuit for us, so all the power consumption or like calculations, everything they have done, and they have kept all the board ready to use. This button is restart button. This button, when you click on this button, the program will start from beginning. So if you're running a program, then if you want to start it from beginning, you can press this restart button. And the program will start flow from first. Then this is power adapter, like 5 volts power. You can give external power adapter to power up this board. And this cable is will come from your laptop. In real hardware, this port is to connect with your laptop. You have USB to this. I don't know which pin is this. You'll get a converter cable also. You should buy that. So you can connect this, and you can if you connect this, it will directly power up this IC. But when you are not connecting your board with your laptop, you should give power to this thing. This is a 3mm jack, I guess. You can connect the jack, like you'll get the batteries, rechargeable battery. They give you a jack also, so you can connect the jack directly and you can power up this microcontroller. So looking to the pin configurations and all, we have this section is for powering, and here we have analog pins, and this is completely digital pins here. So first we'll look into power pins. So we have two grounds, one V in. Even you can power up this board using this jack, 3mm or 5mm jack, I don't know this, but you can power up here, or you can give to V in. If you give 5 volts power supply to V in, and ground it, then also your board will get powered up. Then this 5 volt and this 3 volt is microcontroller will give you
Okay, I
the,
can see.
yeah. What was the question? What a, someone has,
Sorry, nothing.
someone is unmute. You're asking or what? Is someone asking any? What happened? I'm audible, right? Hello.
Yes, yes, audible.
Yeah, you're able to understand, right? What I'm saying. You can see my cursor, right? Like where I'm pointing. Yes or no? Yes. No. Hello.
Yes.
Yeah, okay. So this 5-volt pin and 3-volt pin in a real Arduino board also they will mention like this. It will be written everything like this only. You can see everything same in the real hardware also. So this 5-volt is the microcontroller will generate the 5-volt and give you here. If you want to connect some like sensors, you should power up that also. You can take that 5 volts from here and you can give to the sensors. Some sensors will take 3.3 volts, some will take 5 volts. So our microcontroller will generate both voltage. It is given in different slots. You can take the power from this pins. And we have two grounds, ground here, and also you have a ground this side. So all grounds are same. You can connect anywhere, but every circuit you connect to the microcontroller should be grounded. So you can connect anywhere. All the pins of this ground are one only. They've given different slots because you can connect many sensors and you can ground it easily. Then we have analog pins. So these, we have only 6 analog pins in this Arduino Uno. In Mega, you'll be having many more analog pins. For Uno and Nano, it is same, I guess. It will be only 6 analog pins. So analog pins are to read the analog data. In sense, yeah, we'll run this microcontroller in 8-bit resolution. There is something called bit resolutions. We can run in 8-bit or 10-bit resolutions. If it is 8-bit, then the value will range from 0 to 255. If it is 10-bit, the value will range from 0 to 1024 or 23. Okay. So like the 5 volts, this pins will maximum, every pin in this will generate or will take maximum of 5 volts. So you'll divide that in analog pin, you'll divide that 5 volts into 250 255 times, so that you can generate any like in between voltages like 2 volts or 2.5. It is, if you divide 5 into 2000, I mean 255 times, that is the resolution they say. So you can go to like 2.33 volts or 2.3 like precision. You can go with the precisions. If it is 10 like 10-bit resolution, the precision will be very high, that you can go like 3.333 voltage, like that exact voltage is there. So it can read or write, I mean read, I mean it can take that voltage or it can give that voltage. The board can take the voltages or give the voltages in analog pin or digital pin. In digital pin it can take or give only 5 volts. It can give 5 volts or it can take 5 volts. Taking in sense reading from the sensor. If sensor is getting some like sensed with some thing, like it depends on the sensor to sensor. If it is a gas sensor, if it detects a gas, it will generate a 5 volt in a sensor. There will be a pin which will generate a voltage whenever the gas is sensed. So that voltage you should read. I mean, you should give to this board so that it can understand that I'm getting some voltage. I mean, I'm getting some signal. So it can read the signal or it can generate a signal. So these pins, time out.
45 minutes వస్తుంది
45 minutes time out.
అంతే జూమ్ మళ్ళీ లాగిన్
అవునా?
పెయిడ్ అయితే అన్లిమిటెడ్, ఫ్రీ వాడితే
రిమైనింగ్ మీటింగ్ టైం ఇంకా 10 minutes ఉంది. నో ప్రాబ్లం. I'm audible, right? Hello. Hello.
Yes.
Yes, you are.
Any doubts till now? Like you didn't understand any term or something?
బాగా అది 8-bit precision ಹೇಳ್ತಿದ್ದಲ್ಲ ಇನ್ನೊಂದ್ಸಲ.
What? I didn't get you. I didn't get
8-bit
yeah, there is like
resolution, 10-bit.
8-bit resolution and 10-bit resolution. It means that you can divide something into those many times. If you divide 5 volts into two, what is that? Wait, 255 times 5 divided by 255 is 0.019. So you can start from voltage 0.019. You can like you can vary the voltage in terms of 0.01. You got my point, right? You can generate 0.01 volt, you can generate 0.02 volt, 0.3. So resolution, you got my point. If you use in 10-bit resolution, even I don't know how to use an Arduino in 10-bit resolution. Normally it will be in 8-bit only. We can use in 10-bit also. So that for that you should manipulate some things like port. You should change some ports and the crystal things like even I don't know how is that done. So if you divide 5 by 1024, oh, 0.004 will be your minimum. Like you can generate 0.004 volt, 0.008 volt. So that small voltages you can generate, you can vary in the terms. You got my point? Scaling factor is same, right? You can scale the things like 5 volt will be scaled in 0.01 in 8-bit. So you can vary 0.01, 0.02 like that in the voltages. Got my point?
Yeah, but this can be done in only analog pins, right?
Yeah, this can be done only in analog pin. In digital pin, it will give 5 or it will take 5. It will 0 to 5. I mean 0 or 5. In this 0 to 5, you can vary. You can vary like 2 volt. You can give 3 volt. In motors and all, right? To vary the speed, what you'll do? If you give 12 volts, it will be running very high speed. If you reduce the voltage, like it should be 12 volt motor. There are different types of motor also, like 9 volt motor, 12 volt. So if you take 12 volt motor and you apply only 5 volts, the speed will reduce. The motor will rotate in very like it will not rotate in whatever RPM they have mentioned. If you give only 12 volts, then only you can achieve the maximum speed or the maximum RPM. So to vary the speed, you can use the analog pin, and you can vary the speed of the car. If you are doing some car or something, you need a more like you can vary the speeds there in the motor by using analog pins. This can also be done in digital pins. In digital pins, okay. First, I'll mention the digital pins, then I'll say how to do that thing in digital pin also. So here we have 0 to 13. So 13 digital pins we have. First one is mentioned as RX and TX. 0 on first pin, we have RX and TX, it is mentioned. That means RX is, it is a receiving, then TX means transmission. So this pin, 0 pin is used for receiving any what to say, transmitted waves, or TX is used to transmit some waves. If you use Bluetooth, you can also use Bluetooth module to this Arduino. To work with the Bluetooth, you should connect the RX and TX pin to this pins only. Only these two pins will support your RX and TX. And it is mentioned which pin is for RX and which pin is for TX. I'm audible. I can't. I'm audible, right? Someone sent me.
Yeah.
So in RX and TX, if you use a Bluetooth module, here we don't have Bluetooth module. If it is there, I can have shown you. There will be RX and TX in any like wireless thing, right? If you use any wireless modules, you'll have RX and TX to transmit and receive data. So you can connect those things to these pins and you can work for RX and TX. So maximum here you can connect one, only two pins are available. So you can connect one Wi-Fi module or one this thing like Wi-Fi module. It will be having its own RX and TX. It will have a board. For Bluetooth, it doesn't have a board. You should connect to this. So you can use here only to this pin. You can use this Bluetooth thing. Then we have 2, 3 to 13th pin. Everything is same. Only difference is you can see some negation symbol in front of this number. That means only these pins allow you PWM thing. PWM, pulse width modulation. You know that, right? I think last time only we have studied about it, PWM. So width of the pulse will change in the digital signal. We can vary the width. So only this negation, whichever number having negation in front of it, will allow you PWM things. If you have some application, like as I mentioned, to vary the speed of the motor, you can use analog pin, or also you can use this PWM. In microcontroller, we have studied this thing also. By varying the PWM, we can vary the speed of motor. In some experiment, we have that in the lab. So there in this pins, you can connect the motor and also vary the PWM width of the signal So by that also we can vary this speed of the motor. Also we can use servo motors. We have something called servo motors. These motors will rotate according to the angle, like 1 degree, 2 degree, how much ever angle we need from 0 to 180 degree. If this can rotate this servo motor, so we can mention the angle, at what angle it should rotate, from 0 to 90 only, or 0 to 30 degrees something. So to work with this thing, we need a PWM signal. So we can use this negation kind thing. No, only negation kind thing will allow us PWM. It is mentioned here, digital PWM, some same symbol hyphen. So this means only these pins will allow you PWM thing. So you can use, and the plain numbers are right, they can be used as a digital pin to generate a signal high or low, 0 or 1 we can generate in this pins. Any questions? Like, is it clear? Anything to be cleared? Hello?
bro, no doubt.
Huh? I didn't get you. Come again.
No doubt.
No doubt. Okay. And in this, we have LEDs on this board. Okay. So here you can see it is mentioned on. This is an LED. It means if the board is on, then this LED will be glowing. Okay. Then here we have TX and RX and white thing. This is an LED. So if you are using TX and RX, then this LEDs will be glowing. Okay. Whenever the TX pin goes high, you can see LED going high. If RX pin is going high, then you can see this LED. And here we have a L. This is LED, inbuilt LED we say. So this is connected to pin number 13. So this pin number 13 is connected internally to this LED. So generally to use an LED, we use pin number 13. This is inbuilt LED. Okay. So this board has inbuilt LED. So it is connected to ground and 13th pin of this board. You can connect anywhere LEDs, and you can also use the LED in other pins also. This is inbuilt LED. It is connected to pin number 13. If you want to work with this LED, you can program it for 13th pin and you can use it. Any doubts now? We'll look. Okay. It is showing less than 1 minute. I think this session will close in 1 minute and I can restart, because I'm not using paid Zoom. We'll see. Am I audible now? Any doubts? Any questions? Hello.
Yeah, bro.
Okay. So here in this software to code, we have section called code here. Okay. So in this software, we have three types, like two types of coding. One is block coding. This is called as block coding.